All right, good morning. So, didn't have a chance because our internet's been down. Didn't have a chance to video the lesson this morning, so I'm going back and I'm just doing a lesson, just me and the iPad talking. So today, what we discussed in class, I started out by giving an application component to solving systems of linear inequalities. So where we started today in class was an actual situation here, and this has to do with a student who's in a Boy Scout camp, or he's wanting to attend a Boy Scout camp, and he's selling popcorn to raise that, and we're trying to figure out what's the best combination of small bags of popcorn and big bags of popcorn to be able to go to camp, raise enough money to go to camp, and he could also earn a badge if he sold so many of those bags. So what we're doing here is we're going to take the information they give us and we're going to create two inequalities, and we will graph them on here, and what's going to happen in a second is you're going to see that these two inequalities, the shades are going to overlap. And what those shades will represent is all the possible combinations of large bags and small bags. So let's just jump right in, work this one out, and I'll explain in more detail. So he wants to raise money to attend a Boy Scout camp, and he's selling these two types of bags of popcorn. So he has a small one that he's selling for $4, and he has a large bag that he's selling for $6. So and there's two situations here. So he needs to earn at least $300 just to be able to go to the camp. So I'm going to create an inequality that's going to reflect how much.
Jane Spears to come to the office. You're checking out.
Sorry. To represent how many bags he will need to sell in order to at least make $300. So here's how that'll look. So I'm going to call the small.
I need Brandon Smith and Alex Easterwood to come to the office, please.
I want to call the small bags X, and I'm going to call the large bags Y. So I'm just assigning a variable name to them to get going. So I can write an inequality because it says right here he has to sell at least $300. So that means he could be $300, could be $301, could be $5 million. So he has at least make $300. So that implies the symbol right here, the greater than or equal to. So when I write the inequality, I can say 4 times the number of small bags plus 6 times the number of large bags. So my sales based on these has to exceed or at least be the same as $300 in order to be able to go to the camp. So that's my first inequality. Now the second one that I'm going to be able to create here is this. He said he'll also earn a badge if he sells at least 60 bags. Now this doesn't mean like this has nothing to do with the profit he's making off the bags. It's just if he sells small bags and large bags, if he gets at least 60 of them, he gets this little badge that goes on his vest.
I need Price Wells to come to the office, please.
So I can write an inequality that would say this: small bags plus large bags be greater than or equal to 60. So I have my two inequalities here now. So with these, I need to figure out, because these are in standard form. So I've been showing in class how to convert those over to slope-intercept form. Those will help us get a little bit better feel for how I need to scale my graph, because right now I have no scales. So I'm going to come up here real quick and show you how to convert them. So for the moment, we're just going to pretend that this is an equation. So I did this on purpose, not by accident. I'm converting to slope-intercept form. So if you'll remember from like the first few days of school, we talked about that's the form that slope-intercept's in. So we're going to get y alone. So I'm going to subtract 4x from both sides. So I got to get the 6 away from the y. So that's been multiplied, so I got to divide. So this right here is just a review of basic algebra skills that you learned in 9th grade. So that'd be a negative 2/3 x plus 50. So I know this about my y-axis at least. I at least know that I'm going to have to be able to represent 50 on my y-axis. But let's do the other one, and let's see what it's going to look like. So that's the first one. My second one, the x plus y, equal to 60. Still solving for y, so I'm going to subtract x. And it's in slope-intercept form now. So I need to make sure my y-axis represents 60 units. So I'm going to come back over here to my graph. Let's go ahead and label our axes. Probably should have done that at the beginning, but that's fine. Now's a good time. So the x-axis represents the small bags. And the y-axis is the large bags. Okay, so I'm going to figure out, so I got it, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I go up by 5s, that should easily give me 60. I'll have a little extra, and that's fine. So I'll do 5, 10, 15, 20, 30, 35, 40, 60, 65.
I need Zane Spears to come to the office. You're checking out.
I apologize. Apparently there's a lot of people wanting to check out today. Alright, so our small bags. Now, so there's really not a set scale that you have to do this one with, but I'll give you this hint. It's better when you're graphing. It's better if your scales, if they can be a 1-to-1. What I mean by that is, since I'm going up by 5s here, I go up by 5s here. That makes it easier when, like, you're counting your slope. If it's a 1-to-1, then I know when I drop 3 and run 2, I know that has the same meaning. That's why I say that. So we'll go ahead and make this. There, okay, 65. All right. So with my first graph here, so we'll do that one. So we'll go up to 50. I want to drop 2, run 3. So graph my line. Drop 2, 1, 2, 3. Let's give me another dot there to work with. Okay. So I got to figure out which side of my line should I shade on. So just like with our graphing inequalities, I did a video before on how to graph in linear or systems of inequalities. So what I do is I'll just pick the origin again, and I'll test it in my original. Remember, always go back to the original function. So I'm going to take 0, so it's 4 times 0 plus 6 times 0. So all that equates to 0 greater than or equal to 300. So we have to ask ourselves a question. Is 0 bigger than 300? Well, no. So what that means is this statement here is false. So I put this number in. It did not work. That means I'm going to have to shade on the other side of this. Because remember, the shades represent all the solutions that are true that would satisfy this inequality. So I'm going to shade. I'm going to shade all of this. I'm going to do this other one in another color here. At least I think it's another color. So the next one here, 60. So it's 60. And it's drop 1, run 1. So go in. Now if I keep my line right here. And what I'm going to do is the same thing. I'm going to I'll test 0, 0 again to see if I'm going to shade on this side of the line or on the other side. So 0 plus 0. So is 0 greater than or equal to 60? And the answer is no to that, right? So it's a false statement. So I'm not going to, on this line, I'm not going to shade this side. I'm going to shade on this side. So it's going to shade something like this. So what you'll start noticing is the area where the shades overlap one another. That area is going to be from here and here. So this little bit of shading right here and this little bit of shading right here, I really don't even care about that area because that's not where both shades are overlapping. It's just one or the other. So this area, this is where all the possible combinations of small bags and large bags could satisfy his scenario here. Could he go to camp? And will he get the badge if he goes to camp? So let me model that for you. What that means is, remember, all my X values are small bags, my Y values are large bags. So if I take, say, this point right here, that's 45 and 40. So if I take 45 and 40, remember the 45 is your small bags, that's your large bags. If I take it into, let's see if he's going to have enough money. If he sold 45 of these small ones, 40 of these large ones, let's see if he has enough money to go to camp. So I'll take the top equation because that was talking about the money. So it'll be 4 plus 45 plus 6 times 40. So 90, 180. Zero, 12, 3, 420. Oh. Alright, so so if he sold 45 small bags, 40 large bags, he would make $420. So that's that's 120 more than what he needs to go, right? So he's going to be able to go to camp if he can pull this right here off. Okay? Let's see if he's going to get the badge. So the badge was, if we took the small plus the large, if it exceeds 60, then bravo, he's going to get the little badge and feel real happy about himself. So we got 45 plus 40. So that's going to be what, 85? So that means he'll have 85 bags sold. So that means he's going to get the badge. So yay, Alec! He's going to get to go to camp, and he's going to get a badge. So yay to him. So all of this is an application of the stuff we learned with systems of inequalities, how to graph them. We're taking it beyond just arbitrary. Here's a teacher said, go do these equations, make sure you can graph them, and best of luck to you. These actually have a real useful application to them. They can actually help solve a simple problem like this if it's a linear type relationship. So if we look up here on my my wall, I want to show you. I didn't show this in class, but I'll show it to you now. In order for y'all to be able to look up, I got to push this up. So let's see. Will it follow me? Is it going to? Well, I suppose it won't do that. Okay, but what I was going to show you is so when we're talking about like the depth of knowledge. So when our level 1, is talking about like how to recognize, recall, calculate, and identify. So we're talking about basic algebra 1 levels being utilized here, such as knowing what an ordered pair is, knowing the pattern in between it, knowing how to plug things in, recalling what a linear is. That's our level 1 stuff. We know that just going in. Our level 2 is like identifying patterns, graphing. So this right here is like just simply getting the line on the graph is a level 2 type of mastery. So when we move up to level 3, we are starting to draw conclusions and we're assessing. So when we was up here looking at this word problem, we were looking and reading and we was drawing conclusions like, okay, so, and we started thinking, okay, if he sold this many bags, could he exceed 300? And we started getting an idea in our head. And we started assessing some of that, just maybe in our minds, as we was even reading the problem. I know I was. But our fourth level is where we apply the concept. So the big concept is graphing a system of equations or inequalities and making that answer meaningful. So what we've done here is we have gone to the highest level of understanding, and we've taken a very simple concept of graphing a line, understanding what the x and y values mean, and we've applied it to an actual real-world concept. So this right here is a very relatable concept that we could easily see ourselves in, especially if we have kids that are in Boy Scouts or Girl Scouts. You know, maybe it's Girl Scouts that like selling the Girl Scout cookies. I don't know. So there's real application for this. Let's do another one. Let me erase all this. It always hurts to erase all that because I'm like, man, that's such nice looking work, and have to erase it, start all over. It's always sad. All right, so number 9 here. So in this case, he's got so Greg, he needs to sell at least $1.60 in stamps. All right, so I said sell. I don't know why I said that. I'm still stuck on the last problem. He needs at least $1.60 in stamps to mail a package. I'm sorry. So right there, keyword at least. That's greater than or equal to. We know that right out of the gate. So he has these 2 types of stamps. He's got the 28-cent stamps, and he's got the 4-cent stamps. So one thing that a lot of people forget to do, they intuitively they know that when I say 28 cents of a dollar in a decimal form, that'd be 0.28. But a lot of times we'll forget to actually write that down. So one word of caution: whenever you're dealing with cents and stuff, make sure you got the right decimal in the right place. Okay. So like 28 cents would be like 0.28, 0.04, not 0.4, right? 0.4 is 4/10. So pay attention to that. So 0.04, that's 4 cents. So these are the 2 variables I'm going to be using. These 2 here. So I can call the 28-cent stamps, I can call that my X, and I can call that my Y. And so it goes on to say, so he can use no more than 20 of the 4-cent stamps, since he only has 1 book left. So I see right here with just this information, if I want to figure out like money-wise, so how much money does he have to play with? I see it like this: 28 cents times the small stamps plus 0.04 or 4 cents rather times your Y stamps, at least $1.60. So I have an inequality right out of the gate. So there's one of them. Now it says right here that he can use no more than 20 of these 4-cent stamps. So remember, we call the 4-cent stamps Y. So I'm going to say the Y stamps. We'll say that just to make sure we got clarity here. No more than means he can use 19. He can use 20. He cannot use 21 because that's more than 20, right? So we're using the less than or equal to symbol for this one. So your second one is actually going to be a relatively easy one. Your Y or your 4-cent stamps is going to be less than or equal to 20. So that's what I have to graph there. So when I go through, let's take this over here. Let's convert it over to slope-intercept form. So 0.28x, 0.04y, Again, I'm using the equal sign because I'm just moving it over. I'm trying to keep the familiarity there. So we subtract 0.28. Oh my goodness. Okay, so we're going to divide. Now, since I'm having a dumb moment here, let me grab a calculator. I think my brain's just shutting down on me. So, let's see, we got 0.28 divided by 0.04. Okay, that's going to be a negative 7x. $1.60 divided by 4 cents. That's 40. Okay. So, I have got to make sure that my y-axis will accommodate up through 40 at least. So, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 28. No, it looks like we're going to probably need to use, I don't know, let's do 4s. So, 4, 8, 16, 20, 24, 28, 32, 36, 40, 44, 48. Okay, so since we're going up that way, and remember this right here is representing your 4-cent stamps. This is your 28-cent stamps. I'll do the same scale, just keep it 1 to 1. Okay, so our first one will graph it. So it's negative 7x plus 40. So 40, 1, 2, 3, 4, 5, 6, 7, run 1. All right, so we got a really steep line there. So let's line that up. Okay, so there's my first line. So I'm going to take 0, 0. We'll plug it in to my original, right? So 0.28 times 0, 0.04 times 0. So that'd be a 0 greater than or equal to $1.60. That is certainly false. So I'm going to shade on this side of the line. Okay. My second one is this y is less than or equal to 20. So y is less than or equal to 20. That's a flat line going this way. And it's everything less than 20. So don't really need to go beyond that line because that's going to be kind of a barrier, right? So really the only solution area that I'm looking at, and I really even care about, is truthfully this area right here. So if I took any point inside of here, I'll do one real quick. Let's say I did 20 and 4 right here. So if I did 20 and 4. So this is the 28-cent stamps. This is the 4-cent stamps. So if I said 0.28 times 20 plus 0.04 times 4, will that exceed $1.60? That's oh goodness. Didn't mean to touch that. My bad. So 0.28 times 20. Yeah, that's 560. 0.04 times 4. 0.16. So that plus 5.6. Okay, so that's going to give me 576. All right, so that means that I will exceed $1.60, so I'm good. So if I check the y value, so my y value, 4, is it less than or equal to 20? Yes. Yes. So it'll be just fine. So there's another example. I'm going to pause this video for right now, and when I come back, what I'll do is I'm going to take it a little bit further with this concept we call linear programming, which is just a more precise application of this. And I'll explain a little bit some of the similarities, which are a lot, and some of the differences. So I'm going to pause right there. All right, make sure that thing still worked. All right, so coming back, talking about linear programming. So this is very similar to graphing system of linear inequalities because we're using the same mechanism, same way we go about setting up the problems and graphing them. However, the difference with linear programming as opposed to just systems of inequalities is how we're using the information really. Like where before with the systems of linear inequalities, we would we just stopped at basically saying that any combination in the shaded region would satisfy the problem, whatever the case might. Like back with the bags of popcorn, any combination in that shaded region, any ordered pair would. The small bag and large bag would satisfy that those constraints. Well, with linear programming, the difference is I'm looking for the most optimal solution. There may be a bunch of different solutions, but like if I'm using this in terms of like projecting profit, what would give us the most bang for our buck, so to speak, I'm actually looking for certain actual points. And just at the outset, I'll tell you this, what's going to happen is you're going to have these shaded regions, okay, overlapping, and it's going to form some sort of shape. Like it might be some polygon, it could be an actual triangle or a square. I mean, that's the shape ain't necessarily the point, but it's the vertices of that shape is the things that we test in a function that we'll call what's called the objective function. So a few little terminology differences here, a few different ways we're using the information, but all in all, really the same approach. So let's just jump right into this one. I might need to zoom that in a little. Let's see if I can. Okay, so another definition is constraints. You actually know what this is, you just didn't know what it was called. When we write the little linear inequalities, those are what's called constraints of the function. So this right here is so you got this airline fleet. They on their smallest plane, they offer two types of seating. They have first class and they have tourist class. So you got two different types of seatings. And they can hold a maximum of 50 passengers. So I have these two types of seats. So I can, and that's pretty much what we're working with. We got this airline, and what they're wanting to figure out is, in the end game of this thing is what combination of seats sold is going to give them the best profit. Is what this goes for. So if you kept reading, so. In order to charter a flight, airline must sell at least 8 first class and at least 20 tourists. The company makes a $40 profit for the first, a $30 profit for the tourist. In order for the company to maximize its profits on a single flight, how many first class and tourists? So in other words, I'll summarize a little bit. Basically, they got these two seats. What's the best combination of first class and tourists that's really going to give them the most bang for their buck? So that's what they're asking. So with this first one, I right in the first sentence, I see a constraint that I can write. So I have first class. We're just going to call that X. We're going to call the tourist Y. So those two together can I have a maximum capacity, right, of 50 passengers. So I can have less than 50 passengers, or I can have 50, right on the money. So my first class plus my tourist class all together, that will get me, that will represent just the different combinations. So the second one, they say you, in order to charter a flight, an airline must sell at least, well, there's that term again, we know that's greater than or equal to, 8 of the first class. So X represents the first class. So I can write another constraint that says X is greater than or equal to 8. There's another constraint. I can then go and read further. It says, and at least, okay, again, 20 tourist class. So I've let the tourist be Y. So I can say Y is greater than or equal to 20. All right, so I got some constraints here. So I'm going to have a line that's going to do this. I'm going to have a line that's going to do this. I'm going to have a line that's going to do this. So I'm pretty well got a boxed in looking figure going to happen. I mean, not a box literally, but an enclosed figure. Now, if you go on further to read, it says the company makes $40 profit for each first class and $30 profit for each tourist class. So since profit is what we're looking for, these are going to be used to write what's called the objective function. You can barely see it written down here, but we're going to say P equals $40 times X, because X is my first class, plus $30 for my Y. Okay, so this right here is called the objective function. So what's going to happen is I'm going to go through, graph these, I'm going to shade them, I'm going to find the vertices, and I'm going to take those vertices, because it's going to have an X and Y coordinate, right? And I'm going to plug them in here. And what I'm going to look for is which one of them, when I plug it in, gives me the biggest number, the biggest profit. So here's how this will go. So this thing right here, let's go ahead and convert it to slope-intercept form. So subtract the X. So I got Y equals negative X plus 50. So I know my Y-intercept is going to have to be 50. I'm going to have to at least accommodate for 50. Another one right here, Y is 20, so I know it's going to be. So if I accommodate for 50, then 20 is taken care of. So how many lines here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Brianna Ramos, I need you to come to the office, please. Brianna Ramos.
It's almost like they wait till I'm teaching them. So it looks like the best way to do this is going to go by fours again. That's fine. So 4, 8, 16. Oh my gosh. Losing my mind. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. You know, I was trying to think a second ago. On my previous graph, I can't remember if I put 12 down as one of the... Well, if I didn't do it on this thing, I should be fine. If I did do that, I apologize. My brain's just kind of right now. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. All right, so while we're at it, go ahead and label our axes. Okay, so this is going to be my first class. This will be my tourist class. Okay, so 50. So 50 is going to be right in between 48 and 52. So there, we're going to drop 1, run 1. Drop 1, run 1. Drop 1, run 1. Okay, so we should, if I have my lines about right, should be about here. So there's my line. All right, so I need to test for a shade. So 0, 0. Okay, is 0 plus 0. Is 0 less than or equal to 50? Yes. So this time I'm actually going to shade. All right, so there's my first inequality graph. The second one, let's do that in a different color here. Let's do, we'll do those two. Oops. Oopsie. So x is greater than or equal to 8. So 8 is going to be a vertical line. I failed adventurism. I tried to do that without a ruler. So everything greater than or equal to 8. So that's going to be going this way. If you'll notice, I'm not doing the whole graph. I'm actually doing the whole thing anymore because I think by now we should start seeing kind of where it's going to shades or overlap and all that. So we should be kind of getting to that point by now. All right, y is greater than or equal to 20. So here's 20. So everything greater than or equal to, so my 3 shades are all overlapping. I'm gonna highlight this. Let's see, I'm gonna do it like this. So now, just to cut down confusion, I'll even take that out. So really, I can even take this out. This is not really even important to me. So really, I'm just looking at that shaded area there. And I'm looking at these vertices of this shaded region. So this one, that's an easy one. That's 8 and 20. This one, okay, so I know that y coordinate. I know it's 20. I know that without a shadow of a doubt because you follow 20 over, there you are. But now that x is a little hard to discern. So now we can look at our graph and we can guesstimate. You know, it's between 28 and 32. We know that without a doubt. So when you run into a situation like this and you don't have a calculator that you graph these and you can find those intersections, what I do is I say, okay, let's step back. What lines are intersecting and making that point? So I see this line here, which was represented by this inequality. I see this line here, which was represented by this inequality. So I'm not interested in the shades anymore, right? I'm interested at the intersection, the point where they converge. So I'm looking at a system of equations here. 2 lines intersect, form one point, that's one solution. I know how to handle that. I can look at these and I say, okay, I'm looking at it from an equation standpoint. I can say x plus y equals 50, and then the other y equals 20. So what I need to figure out is, well, what on earth is what's my x value? So if I know y is 20, let's just put 20 where y was on the other one. So that's the x coordinate. And we even said at that point, you know, it falls in between 28 and 32, so that's perfectly reasonable to suggest that it would be 30. So it works. So there's my second order pair. This one, I don't know what I was doing there. I know the x coordinate is 8 because it's coming right up, being formed by that line, x equals 8 line. The y coordinate, a little harder to discern. We can probably, we know it's between 40 and 44, so we would probably think 42, but you don't want to guess, you want to be right. So I can look at this just like I did that other one. So I know this line, which is this inequality, and this line, which is that inequality, I can, like I did on the previous one, I can set those up and figure out that point of intersection. So what I'm going to do is I'm going to go back to this now, and I'm going to say, all right, x equals 8. So we'll put 8 where we see the x. So we got 8 plus y equals 50. Lo and behold, I mean, we was actually right. Our graphing was pretty spot on, so we was able to pretty well guess that one, but I don't want to guess, I want to know. Because, as the old saying goes, guessing only, or close only counts in horseshoes and hand grenades. So we're dealing with neither of those, so I want to be precise. So let's recap. Graph the inequalities, found the overlapping shaded region. We noticed it formed a figure. This time it actually did form a triangle. That's nice, ain't it? Doesn't always happen that way, but that's okay. I'm looking at the vertices. So one of these 3 vertices is representing the optimal combination of first class and tourist class combinations to really get the most profit. So here's how we're going to figure that out. I'm going to take that objective function, and I want to take each ordered pair and plug them in and see which one works. So we'll take 842. So that's going to be 40 times 8 plus 30 times 42. So 0, 320. So it'll be what? 420 times 3, 6, 1260. Yeah. So 1580. So this will give me 1580 profit. Let's try 3020. So that'd be that'd be 1200. That'd be 600. So that would be 1800. That's looking pretty good. So my last one, 8 and 20. 40 times 8 plus 30 times 20. It's 320 plus 600. 0 to 920. So my maximum profit is going to be this combination of first class and tourist class. So that, since it gave me the largest profit, that was my my best combination. So this is my optimal combination for my profit. So linear programming. Whew. And this right here was one of the more direct upfront ones. They can get pretty tedious, just depending on how many different constraints. But if you'll notice, this right here by far is the highest level of knowledge dealing with, at least in Algebra 2 level, that is, dealing with systems of inequalities and all linear inequalities and such. So these, I'm only going to work this one. I'll let you try a couple more on your packet yourself and just see kind of how you do with it. If you have any questions, then you can certainly email me at evest@ccboe.org, and I'll be happy to run over and help you with those. Okay, so thank y'all. Y'all have a great day. Happy studying. Bye-bye.